I don't see it on your screen.
On your screen, are there any camera? What do you see on your screen?
Yeah, I see cameras, but you can like change the layout. So
Yeah. Anup, what do you have your layout as? Oh, Anup, it started streaming. Do you want to like pause that for a bit?
I'll sit here.
All right.
During the presentation.
I think we might be live, possibly.
Okay, so then like we can just keep ourselves muted and like turn off our video like whenever we're not presenting, right?
Yeah.
Okay.
Okay. So I think we are live. Yeah. So hi everyone, welcome to Z.I.P Talks. So this is our virtual summit where we're hosting different teams. So this year we have Team Z.I.P Ties, Team Uplift Robotics, Team Pink Team, and Team Gears of Fire. So I'm very excited for this year's Z.I.P Talks, and we're just gonna give it a couple of minutes for some people to join, and then we'll get started with the presentations. Okay, everyone, so we're going to go ahead and get started. So I just want to introduce some of the teams that we have. So we're Team Z.I.P Ties. We have been a team for 3 years. This is our third season in FTC. And we just won the second place Inspire Award, our league championship. We're along some pretty amazing teams. So we have Team Uplift Robotics, who won the Inspire Award at both the league championships and the state championships. Gears of Fire, who are one of the top ranked robots, and also Pink Team, which won third place Inspire at our league championship and also was the second place highest robot. So we're some pretty amazing teams. So uh, we're just gonna get started with our presentation. So Arian, take it away.
So hi everyone, I'm Aryan Parlaker from Z.I.P Ties. I'm the co-captain of the team along with Sanat, and I'm the mechanical and business lead of our team. So today in Zip Talks, we'll be presenting team management.
Okay. So a little about our team. So like I said before, we're a third year FTC team. And we're based here in Sanford, Florida, in the Space Coast League. We have about 9 students from 8th to 11th grade. Our youngest person is like 8th grade, oldest person 11th grade. We are formerly an FLL team for 2 seasons. We are Team Air 404, Team Not Found. And we won the second place Inspire Award at League Championships, along with the Connect Award and different awards. So we're a pretty experienced team, and we think that we have some good knowledge as to how to start a team, and especially a rookie team, how to get started in FTC.
The biggest thing is starting out, right? Like you could have the idea of having a team, but actually starting a team in first tech challenge is somewhat confusing. So the first thing is gathering team members. There are different ways of doing it, either by talking to people who are interested, people that you know that are committed. And I feel like the biggest thing is that don't always try to go for your best friends because I mean, yeah, it's fun, but I mean, you should go to people with all skill sets, the people that are good with soft skills like speaking, making PowerPoint presentations. And I know it doesn't seem like it'll be a big thing in robotics, but there are things like this, like Zip Talks that we are doing, and other things that like the YouTube videos that Uplift hosts with other teams, and just different things like that. It's not only robotics and building and programming. And again, make sure that you designate roles based on personal interest because at least seen through when we tried doing it in first Lego League, even in first tech challenge, the biggest thing is that you want a team where everyone is having fun and enjoying. And that's just talking about team members. And I feel like the next thing is contacting your regional director. It is on the FL First and the FTC website. Just shoot them an email and they're very fast and they will respond. And the next thing to actually start your team in FTC and actually be known by first is to register your team on the first website. That team will just be setting up, and you need to have a designated coach and assistant coach for every team. And I feel like the next thing is that when you're starting out and maybe you're in the process of gathering your team members or registering on the first website, start learning about the different aspects. Whether it's learning CAD through SolidWorks or PTC Creo or Onshape or just websites like that, what programs like that, or you're learning programming, how to actually program, or you're busy getting funds and trying to fundraise, just start dipping your feet into it because you don't want to go into the season knowing nothing. It would be best if you guys started to order parts beforehand and just that sort of stuff, just so you could get used to it instead of straight jumping in without knowing anything.
Yeah, so once the first step of like starting your team is to build your team. So the usual team, the max team in FTC is 15 members, but usually you have around 8 to 12 members. So ideally your members live close to each other or where you meet. In FTC you're gonna have to meet a lot and you have to meet like long hours. So having everyone live close to each other would be pretty good. So it'll be easier to go to robotics and go from robotics, and try to diversify your team members so in interests and also like age, like demographic stuff like that. If your team is all like seniors or something like that, then your team's only going to exist for 1 year and then you're done. So try to make sure your team is like diversified, many different things. If you're like only getting programmers and you have no one to build your robot, no one to get funds to get your robot to exist. So it's pretty good to have a diverse team in all different aspects. It's a really important aspect of first. And once you have your team, you have to get to know each other. Having a team where like no one knows each other is kind of like a chore that everyone does too. It's like it will be not a good experience, and it'll ultimately cause you to be a worse team. So try to get to know each other, know like what your different quirks are. So you can like do some different team building exercises, do icebreakers. For those of you who were in FL before, you know what core values game is. For those who don't, so in first there are different core values that first has. So for the core values game utilizes these core values to have the team solve a different task. So it could be that they have to tangle each other, go like in a human knot and try to get untangled, or do different things like create a story by each person says one word. So just get to know each other, and that'll allow you to be a much more fun team and like be a better team. And then once you know your team, just designate your team roles. Having team roles is like a good thing, so you know who is responsible for what. It allows for like more leadership and delegation as to what is happening. So the way that we determine our team roles is that we figure out what each team member wants to do and what they're good at. So for example, like based on that, I'm good at programming and I also like to do outreach. So because of that, I'm the programming and outreach lead for our team. So once you do that, you can create your role leads. A lot of teams suggest don't having role leads, and that's a good idea for some teams, but our teams personally found it that it's useful to have leads for your roles. It allows for like leadership and for someone to have accountability for each of the different aspects. So once you have your team roles, then you can learn about the different aspects of first and learn about what your role is. Some of the great resources that there are in first are Game Manual Zero, which is gm0.org. It's it's a website created by different FEC teams that talk about all different aspects of first, like judging, programming, robot. It's a really good resource for anyone who's starting to learn about first and wants to know about the different concepts of first. You can also use the FTC Discord. uh, FTC has a Discord where a bunch of teams are there. You can ask questions there, talk about things that you're doing. It's just a good environment and community for you to just learn about stuff. And also, if you're a team in Florida, we have the Florida FTC Discord. There we have like a bunch of amazing teams who are all helping each other out. So you can definitely use those resources to learn more about what you're doing. And you can also contact your other teams. FEC teams love to help each other out. So if you ever need any trouble, just always contact your other teams. They'll love to help you out and just tell you what you're doing wrong and how you can improve.
So another big thing about like starting off a team is fundraising. I mean, building that robot or building a top tier robot isn't a cheap thing. It costs upon thousands of dollars if you manage your money even wisely. So the first thing most teams should do, or what we advise teams should do, is to find a nonprofit that supports you, or make your own nonprofit. Which it's a lot easier to get a nonprofit which actually supports you. A lot of companies that give you funds will acquire a 501(c)(3), which allows them to write off their donations towards you. And most grants will also require this. It's always great to have one. Our nonprofit is ASCE, American Society of Civil Engineers. They've supported us for the past 2 years and will support us this year again. The next thing is to plan your approach, to make a business plan to fund your team. We advise listing down nearby businesses. They will always give some money. The quantity of money is questionable, but how much they will give or how will they give is yes. They most businesses love to support local initiatives, especially STEM initiatives. So it would be a good idea. And while you're contacting those teams, you need to figure out what you're asking them and why are you asking them. You can't just ask teams for money and not teams. You cannot ask just companies for money and expect them to give it to you. You need to give them a list of why do you want them to have it and how much do you need for that reason. And the last thing is, what are you going to give back to them? Whether it's giving them souvenirs or things like that, gifts, advertising their company, for example, putting their name on the back of your team T-shirt or on your robot, or just things like that. What are you going to do? And then the next thing is to actually approach the companies. There are different ways to do it. You could do emailing, phone calls, or even in person. And even though COVID is going on, going in person would be the best thing if available to you guys wherever you guys are located. When writing a letter or drafting an email or making a script of what you want to do, it's best to start off by introducing your team, introducing everyone on your team, identifying the benefits to your team and them. So just going over your approach and obviously thanking them, because I feel like that's the biggest thing. Thanking them, giving them the gratification that they are helping a team in their local area is great to hear.
Yeah. So another important part of first is getting mentors. So it's pretty hard to do everything by yourself and not getting anyone to help you out. But luckily for FTC teams, there are a bunch of different mentors that you can get to help you out on your journey in FTC. So mentors, they can have a lot of different mentors. So like programming, CAD, presentations, etc. So mentors are really helpful in different aspects. So getting mentors, you can get them from anywhere. So a lot of family members can be mentors, friends, colleagues of your parents, etc. Like a lot of our team dads help out with like building different things. Like Anoop's dad, Anoop is on our team. Anoop's dad helps out with like when we were learning how to saw and cut wood and Lexan, he helped us out with learning how to do those, like use those heavy tools and stuff like that. So people just around you can help you out with FTC. Like you might not think that they know stuff about robotics, but their skills that they've accumulated can help you out in a lot of different things. Coaches and members of other teams also are really helpful resources. For example, Coach Rick in Roarbots, the Oviedo High School team, he's helped us a lot throughout our years and given a lot of knowledge. So, like other teams are a great place to get a lot of information from. And like I said before, you can talk about you can always reach out to the FTC community. There's an FTC subreddit. If you guys use Reddit, you can ask questions there. A lot of people are really helpful and will always respond. There's an FTC forum, which is the official first like Q&A site. If you have any questions about game rules or general like things that you want like the first people to know, like if is a part legal or not, then you can ask there. The official first volunteers and game designers will always be there to answer your questions, and or you can also ask in the FTC Discord. You'll probably get your answer there the fastest. The FTC Discord people are really nice, and they'll answer your questions pretty good. So just try to find some mentors for your team and get your mentors to help you out. It's a really good process, and you'll learn a lot from that.
The next thing we're going to talk about is the physical robot parts that you should buy as a team starting off. So the first thing are the basic robotics kits. That comes. Give me 1 second. One of the basic things that you would need to do as a team is get the basic FTC building set, whether it's from Tetrix, Rev, Servo City, which is Actobotics, GoBoda, or Matrix Robotics or Matrix FTC competition set. Ideally, the ones that are most commonly used are Tetrix, GoBoda, Rev, and Servo City. And our team uses GoBoda for everything that we do. The next thing are just getting wheels in general. Most teams now use Mecanum wheels, which allow you to move in all different directions, and they're also sold on AndyMar, GoBoda, Rev, Tetrix, and now Servo City too, because Servo City started selling GoBoda parts as well as Actobotics parts. The next thing is linear motion, whether it's linear actuators or linear slides. All the same companies also will have them. And the most important thing is that designing your drivetrain before the season starts. It's a really important thing to have set and make sure it's fully finished and built, and as well is that it's built so that your team in the beginning has the ability to buy new parts when they need it, to not like improv buy parts, because shipping is really expensive. And great ways to look on that are the GoBoda drivetrain kits and the AndyMark ones, as well as the motors and servos, which are all the powered things in a robot. The same companies also have them. We use GoBuilda servos and Yellow Jacket motors, which are also from GoBuilda.
Yeah. So in order to like actually properly use all these physical robot parts, you have to use some electronics to control the robot. So the commonly used electronic software is the Rev systems. So in order to control your robot, use a Rev control hub or a Rev expansion hub. Use those Rev control hub and expansion hubs. You'll order them from Rev, and those allow you to interface with the robot. This is where you put all your code in to program your robot. And this is like your interface between your robot and your code. So also in order to do different like connect your Rev Hub to do different tasks, you have to use different cables. So the common cables that you use are the XT30 cables for power, and then the servo cables are used for different to plug in different servos, and you also use your sensor cables, which plug your sensors into the I2C port on your Rev Hub. Speaking of sensors, there are a lot of different sensors that you can use in FTC, such as the light sensor, the IMU in the Rev Hub, a distance sensor, and a touch sensor. Those sensors allow you to more accurately know different things about your robot, and allow for a lot of help in programming and your different parts of your robot. And in order to control your robot, you're gonna need two game pads in order to move the robot around during the tele-up period. You also need a battery in order to provide power for your robot, in addition to the rev hubs that you need to port to the robot.
So here's another, when most people join a robotics team, they think it's just robotics and coding, but there is one other aspect of FTC, which is called the Engineering Design Notebook. The Engineering Design Notebook is a documentation of the team season, so their outreach, their fundraising efforts, team plans, and the robot design. And generally, which first requires is that there are three main sections about to your engineering notebook. The summary, which has a brief description of your team, which should be only one page, and the most important, so highlight pages for your judges. The team section, which has the profiles for your team and mentors, giving quick profiles about all of them. Your outreach, which is how you spread the word of STEM and FIRST around your community, and business. So what we talked about before, your business plan, your business strategies, who you reached out to, how you reached out to, and what did you obtain at the end. And the third one is engineering. Your physical engineering, which is your hardware, your CAD, that sort of stuff. Your programming, which is the code and how you work through it, and the team meeting summaries. Team meeting summaries are basically just summaries that you take of every day when you meet, and just that. And just make sure to keep that very organized, just so it's easily used and it's easy to put in your engineering notebook at the end.
Yeah. So what does FIRST actually want you to do? So each year the robot challenge it consists of three different sections. So the autonomous, tally-up, and endgame. So all three sections combined, it comes out to a 2.5 minute match. So in the first section is the autonomous, which is 30 seconds. So the autonomous section, you just place your robot down, and then you run using autonomous pre-programmed instructions. So you have no control of the robot during that. Usually the autonomous section is where you have the highest points. So the autonomous section is one of the most important sections. You also have the tally-up section, which is where you use those game pads that we talked about earlier to control your robot and move it to do what you want it to do. And that tally-up section is 2 minutes. And in the last 30 seconds of that tally-up section is the end game. So in the end game, you can still do the tally-up tasks, but you also have additional tasks that you can do to get even more points. So those three sections are what consist of the robot section of FTC. All the rules for the robot section and FTC in general are in the two game manuals. So right now for next year's challenge Freight Frenzy, Game Manual 1 is released, which talks about the different rules for the notebook, the different awards that you can await in FTC, and the advancement guides. The second game manual contains all the actual game information, which talks about penalties, how to earn points, and different things about the robot rules. First also releases a video that talks about the robot challenge and shows the different tasks that you can do to earn points in FTC.
So the next thing, and probably the last thing, is preparing for the actual competition itself. In Space Coast, there are four main competitions: the 3 league meets and the 1 league championship. Over this year, for COVID, it was different. There was 6 league meets and 1 league champ, but generally it's only 3. At all competitions, an engineering notebook will be required to show, but you will not be presenting it. It will just be there, just to make sure everyone's doing it. And before your competition, it is most ideal to make a checklist of what you need to pack, why you need to pack it, before judging presentation and pre-game presentation. So what needs to be done with your robot before the game, and what you need to review with your team before the judging presentation. And remember, make sure everything is finalized with your robot and program the night before the competition. Ideally, you don't want to make changes to your robot a night before the competition, but things happen. It's fine. Just make sure you're not like rebuilding your robot while you're doing it, and remember to print out your engineering notebook and ideally have it, and actually you have to have it in a binder, and just make sure everything is organized and complete.
All right, so that's our presentation. Does anyone have any questions?
So I see one question is by Mohill, and he said, "Can you connect with FTC alumni?" Actually, yes, you can connect through FTC alumni. FTC has an alumni division, not that they compete in, but it's alumni, and generally you'll see a lot of alumni, serve as your mentors. And in the second picture in the bottom, you see Sahil. He was a member of Super Seven, and he currently still helps us throughout our struggles. As you can see, when we had an issue with our shooter, he did come and help us. And generally, in-person competitions, during in-person competitions, you will see a lot of people there serving. A lot of them are FTC alumni, and you can always go up and talk to them about any questions you have. And yeah.
Okay, so we have another question that is, why should I join First Tech Challenge? So First Tech Challenge gives you a lot of different like skills that you'll use throughout your life. So it just teaches you a lot, not just STEM skills, but also just like soft skills. So you learn how to program and build robots, but in addition to that, you learn how to present different things. You learn how to talk to you know how to talk to companies. You learn how to get sponsorships, and that's like a lot of skills that you just learn from First Tech Challenge that you just don't learn anywhere else. So like it's just a really good experience to be in, and it's just a lot of things that you learn from it.
I think Shrina asked, what is the hardest part of your season? Um, I couldn't see it in the chat, but she texted me that she had the question to ask. And I feel like the hardest part of our season this year was getting our team to, have that fully connected bond, of which at the end of the season we did. During league meets, after league meet like 2, it was fine, but especially in the beginning where everything was fully online and we were in lockdown, it was really hard. In a general season, I'd say keeping up with the engineering notebook. In the beginning of the season, everyone's like, "We're going to do it. We're going to work towards it. We're going to actively complete it." But you do get really, really like distracted from it with your robot. And I feel like the biggest thing, or like thing that I would want to warn a lot of people about, is to make sure you're on top of your notebook constantly, whether it's filling out the engineering section or working on the team meeting summary, making sure all your business plans are fully written down, fully drafted, and everything. Just making sure you're on top of the engineering notebook.
Okay, so Mohil asked a question: what's more important, judging or the robot matches? So judging and robot matches are both really important in the fact that they both will take you to the next competition level. But usually for top level teams, both judging and robot competitions are equal. But if you know your robot is like a little lacking and you're not like one of the top robots in your competition, you might want to focus a lot more on judging because it has the same weightage as a robot. So if you have a pretty bad robot but your judging's excellent, you can still make it to the next competition. So I would say if you're a top level team, they're both equal. So you have to focus on both of them, but if your robot isn't that good, I would say focus on judging a lot. So I don't think I see any more questions. So if that's it, we're gonna move on to our next presentation.
Yes. Wait, does anyone else have any more questions? No, it doesn't look like anyone has any more questions. Yeah, so we can move on to the
Yeah.
next one.
Oh, okay. So last question. I think it's got one. What is your biggest moment that your team experienced in FTC? Uh, my biggest moment, I think, might make my most memorable. So I would say that my most memorable moment in FTC was probably this year getting second place in Spire Award. Like coming into the league championships, our robot didn't perform up to what we were expecting. We had some errors going in our robot while we were running, so we weren't really optimistic about our chances. But we got pretty surprised by winning Inspire Award second place. So that was probably one of my highlights in my FTC experience. Okay, so I don't see any more questions. So next, we're going to go to Team Uplift Robotics, who's going to talk about judging and team presentations. So,
Hello. So we are Team Uplift Robotics. We're a second-year team from Oviedo, Florida, and I'm Chase. I'm one of the co-leads this year, and then Nitin, who's also going to be presenting today, is our chief engineer this season. And we will be presenting judging presentations, so the actual sort of presentation you have to give at competitions, and the awards that you can win at competitions, and how those are ranked.
Yep. So start getting into some of the judging aspects. Okay, so why does judging matter? So at most competitions, judging is a huge part of advancing from a competition to the next competition. So say from your qualifier or your league championship, you'll usually have a list of an advancement criteria or advancement order that's outlined in Game Manual 1, which is like one of the official documents that FTC releases at the beginning of each season. So you can see the advancement order off to the side, and all of the red bullet points there are all award-based uh, advancement opportunities, and the ones in black are robot-based advancement opportunities. So you can see how the red advancement opportunities, the awards, are weighted just a bit higher because Inspire is above the Winning Alliance captain, and some of the other awards are one tier above. So usually at most competitions, you'll have more usually either the same amount of teams that advance off an award, or you'll have one more team that advances off of an award. So judging is extremely important if you want to advance to higher competitions. Also for judging, it often prepares you with like a lot of valuable soft skills that you not just use in FTC, like when you're going to doing presentations to judges and stuff, but also in the real world when you're making things like documentation for either your engineering portfolio or your engineering notebook, presenting to judges in a similar manner to how you present to business professionals, even when you're doing outreach events, presenting to professionals in the industry is an important skill that you need to learn, and also how to handle question and answers. So sometimes you might get thrown a curveball question, then you have to think really quick on your feet and think of an answer to their question or whatever it may be. So these are all really important skills that will help you beyond just what your time in first. And the different types of awards. So like we saw on the other slide, there's a bunch of different awards that you can win from first. So irrespective of the robot-based awards, these are the list of awards that involve judging. So besides the ones that you get directly from the robot game, such as winning alliance captain, finalist alliance captain, and first pick, second pick, things like that, there's the Inspire Award, which is usually given to the top overall team, or the the best overall team essentially in all aspects of first, including outreach, business, uh, including robot. Their engineering documentation is usually the highlight of the team and shows a lot of their growth and a lot of the accomplishments that they've done throughout the season, and highlights all the good aspects of the team, what they've learned especially. And a lot of that is also communicated in the judging session to between the team and the judges. And like it says on the slide, it usually takes about 3 of the 5 advancement slots, or the first 5 advancement slots. So it's a really important award to, you can't really focus on the award because it's a more overall comprehensive award, but making sure your team is at its top level at each of the different aspects of your team is super important if you want to go for the Inspire Award. The Think Award, on the other hand, is based more so on the documentation aspects of the team. So the notebook and the portfolio especially come in handy for this award. And it usually looks at the journey of the team throughout the season and what they've done to document the engineering design process that they've gone through, both for hardware and software aspects of their team. The Connect Award, one thing I didn't mention before, these are all in the order of advancement. So the Inspire Award is ranked the highest, then Think, then Connect, and so on and so forth. The Connect Award is focused more so on the outreach and the business side of your team. So connecting to professionals in the industry, like it says, beyond FIRST, people who are outside of the realm of FIRST, and introducing them to FTC, bringing them into your team maybe as a mentor or presenting at like a professional conference, something like that, will be considered as a connecting award, connecting beyond just FIRST. The Innovate Award is usually given to a team within. This is a slightly more robot-based award, but the documentation, notebook, and portfolio come in extremely these are extremely crucial elements into winning this award. So without an engineering portfolio or notebook, you can't win any of these awards, especially even something like the Innovate Award. You cannot win without an engineering portfolio or notebook. And then the Design Award is given to the award as like to the robot as like an overall an award. So it's given to like a mix of not just a single mechanism, but the overall complexity and the overall reliability design process that went behind the robot, and focuses more towards the consistent parts of the robot. And then Motivate is an outreach-based award that's within the FIRST community. So unlike Connect, which is outside, Motivate is more of the outreach accomplishments that your team has done within the STEM community and the FIRST community. And then last but not least is the Control Award. This one focuses more on the programming aspects of your team. So the autonomous and any teleop algorithms or different mechanisms that your team has in place to ensure consistency and reliability for your autonomous and your robot's performance as a whole is super important for this award. And there's usually a separate Control Award documentation that's also submitted with this award. And this past season, they had a control video that was also submitted with this award. So both of those are also crucial elements for the Control Award.
So now we're going to transition over to presentations, judging, and a little bit of portfolio. So first off, let's discuss what is the presentation and why does it matter? The presentation is a 5-minute presentation in front of a panel of judges that you will give usually at only the higher level competition. So your league competition, your state competition, your world competition, you will give a 5-minute presentation. It is your only chance to motivate judges to look further into your notebook and consider you for awards. At many competitions, they simply do not have time to proactively look thoroughly through every team's documentation. So this presentation is super important to make sure that you hook the judges and have them dive deep into everything you're doing and really are being really interested in exactly how you've accomplished what you have this season. And especially at local competitions, judges get to rarely do field observations, which means like they very rarely have the chance to go watch matches, which means that if you don't mention something in your presentation, especially something super technical with the robot or the way it performs, they may likely never know about it. And the only thing they really know around the time that they select what awards you qualify for is usually a rough estimate of how you've been doing throughout the day. So at a normal competition, you'd compete about 6 times before the finals period, and they probably know about the results of those 6 matches before they have to make that decision. So all they know about your robot really is the numbers that it's performing. So it's extremely important that those design principles, like Nitin mentioned, for both the design and innovate and control award are all covered inside of this presentation. The intention with it is much like your notebook. It's really to tell a story about your season and how you got to where you are today. So that includes everything from how you got funding to how you organize the team to everything you've done with your robot and all of the outreach you've done as well. Like, you really need to tell a comprehensive story from start to finish about all of the challenges you faced this season and how you resolved them. So some tips and tricks for presentation. The absolute key is to make it memorable. No matter how cool and exciting all of the technical information is in your presentation, make sure it has a bit of personality to it that reflects your team. One thing we did, for example, is we're Uplift and we're all aviation themed. So we had a flight attendant call bell that would go off at the front of our presentation, and that just got the judges' attention. Little things like that can make a huge difference as far as making them interested in the way you run your team, and just, hey, this is a little thing that makes us unique. Especially if we end up doing virtual judging again this season, adding little Easter eggs in like that, even if it's puns about your team name, it goes a really long way. Another thing that's super important is practice. Practice, practice, practice. Use every second of that 5 minutes that you possibly can to make an impact. We, for example, had 15 kids this season, and we were able to have all 15 kids present in that 5 minutes. And that is a huge impact on your presentation when they can see, wow, they really had every person on their team talk about what they've done this season. That makes a phenomenal difference than if you have a 15-person team and only 6 of your kids go in the judging. So that is kind of an unwritten rule of presentation that I can't stress enough, is you really want to use all of that time to have as many people talk and to present the information that is absolutely crucial to making them interested in your team. And part of that, as you can tell right now, is excitement. You really want to sound excited about what you're doing. I've had mentors in the past that say it's the best 5 minutes of your life, because that's really what you should be acting like it is. It should be the most exciting presentation you've ever given and the most exciting really 5 minutes conversation you've ever had. Because a lot of these judges, it's really early in the morning. If you haven't done one of these competitions before, they start at 7:30, 8 a.m. The judges have probably been watching presentations for 3 hours. It's really important that you make it sound exciting. And a big part of that is it being interpretable. If your grandmother can't understand it, the judges likely can't either, because you're going through the information so fast that they don't have a lot of time to really think about what you've been doing. And, like, if you start talking about super complex stuff or getting into the nitty-gritty of the technical details, they likely won't be able to pick it up really quickly. So it's really important that you really kind of not necessarily explain things, but write them in ways that quickly explain why you're using them and what they do. And then another huge thing that kind of ended up being our secret sauce when we wrote the presentation last year is the judging manual. That's a volunteer resource under the kind of First Inspires website. And what that is when you see the judges carrying around a binder at the competition, the judging manual is inside of it. That's exactly how they decide what teams win awards, what criteria they use. Even the rubrics that they gave us back at the end of competition last season are in those judging manuals. So when you're writing your presentation, I strongly, strongly encourage that you use that to format it and figure out exactly what information should go in your presentation and exactly what information shouldn't. Because that really can tell you, like, when we wrote our presentation, we went and said, okay, here's design, here's the 6 things they look for in the design category. Let us present about those 6 things and how our team uniquely accomplishes those 6 criteria. So that's one thing that is extremely helpful if you utilize it properly. And the last thing we're going to talk about is, how does the portfolio tie into this? So the notebook and engineering portfolio, as Z.I.P Ties had mentioned, are meant to provide more detailed breakdowns of everything you did this season, and they should support what you said in your presentation. One thing that can save you a lot of time in your presentation is, instead of, like I said, going into the super nitty-gritty details, just talking about the significant things you did and how you accomplished them. If they want to know exactly how you wrote an algorithm or exactly what math you used to accomplish something, they can look at your notebook and figure that out. That will save you a lot of time in your presentation, and it makes the presentation more engaging because they're not like, whoa, you just gave me a 6-degree polynomial. Hold on, I don't need to read this right now. Like, that makes it hard to really understand what's going on. So I do highly recommend writing the presentation as something to support your portfolio and your notebook. And then with both a notebook and a portfolio this year, for those of you that don't know, the engineering portfolio is a 15-page document. And we believe that it should function as a written summary of everything that makes your team unique. So the presentation is the most entry-level 5-minute elevator pitch of your team. The portfolio is about a 10-minute document that you read, and it gives you all of the kind of more written information about your team. You make it sound real pretty and look pretty and be all nice. And then the notebook is really, for us at least, is going to be where all of these super technical documentation goes. So all of our meeting entries, our notebook entries, all of the math we use to design our robot and the CAD drawings and things like that will go in the notebook. So I think that is all we have for our presentation, and we are open to questions. That was pretty fast.
All right, yeah. So we have one great presentation, guys. We have one in chat that says, "Are all team members required to present?"
So all team members are not required to present, but we do believe it's sort of like an unwritten rule. If you read the judging guidelines, there is something in there that says they strongly encourage participation from all team members. So if you go to a competition and I'd say, like, even if you don't have everyone at the competition, I would strongly encourage having everyone that attends going into the judging room. At least in my experience, I've been doing this for 6 years. I've been on 3 teams, and that's been something that always seemed really important to us, is having every person in there really shows that you have a unified team and everyone at least knows what's going on inside of the team. That's been a big difference for us, and I think it separates a big team from other big teams that only have 4, 5, 6 dedicated members. Is it really makes an impact and shows just how large the team is and that everyone is still working even though you have 15 people.
I don't know if there are any other questions. So I'm waiting on to see if there are any more questions because there's a little bit of delay in the stream.
Yeah, no problem.
Okay. One that someone said to me was, "Are all the presentations scripted? Like, do you make a script for presentations, or like, do you just think of it from your head, or how do you create your presentation?"
Ours is usually scripted, especially last year with the whole WebEx scenario. We did pretty heavily script the presentation. When we have in-person competitions, what we usually do is a bulleted list, or if you want to pre-script it, you can. But we obviously, especially when you're trying to cram as much information as you can with 15 people in 5 minutes, we have a very decisive, this person is covering these 3 things and they need to do it in 3 sentences. And this person is doing that exact same thing, but with a different 3 things. And that's one, at least it's shown to be one of our more key factors of our presentation on making sure you run on time every time and you get the information across that you need to. So even if you don't want to script it word for word, I'd actually advise against scripting it word for word and going just with the bulleted list, but making sure that you know exactly the things you need to hit in those 5 minutes is extremely important.
All right, and another one that I got was, how much practice do you usually do for your judging?
It depends, but I'd say that the average team doesn't do nearly enough. I think we last year probably ran through our presentation 2 to 3 dozen times before the state competition. So between leagues and states, we probably did it 2 to 3 dozen times, and we had it finishing between 4 minutes and 58 seconds and 5 minutes and 1 second every single time. So I would just say practice as much as you can physically manage. I know obviously robot takes a lot of priority too, but making even just putting an hour aside out of your, let's say, 4-hour meeting time every week for the first 3 weeks before leagues makes a really big difference. Just making sure that you have that presentation down, you know how to answer questions that the judges might throw at you properly, things like that make a really, really big difference.
Okay, I'm not seeing any more questions in the chat. I'll give him like a minute for the delay to catch up, but if there are no more questions after that, we'll just move on to the next presentation.
All right, thank you.
Okay, so it looks like there's no more questions for Uplift. So next we're gonna move on to Team Pink Team. It's gonna talk about the robot and programming.
Great. So are you able to move it to share my screen?
Yeah, you should.
Alright.
You can do it now.
Whoa. Okay. So we are the Pink Team, Team 6323. Our FTC branch has been around since 2012, and throughout those seasons, we really try to make really great robots and judging too. But in this particular presentation, we'll be talking mostly about the robot and how you make a good robot and how you plan it out, along with the software that goes into it. So I'll start off with just some common robot components. So first off is power transmission. How do you get power from the motors to your mechanisms? So first one I'd like to talk about is belts. You can see a little bit of a picture of a belt right there. That was on our robot this year. So they come in different formats. They can be round. So round belts are just round. They pretty much just transfer torque by friction. So that's why I typically don't like them, because they can slip, but some teams find good uses for them. So the tying belt is what's shown here, that has teeth on them, so they have less of a chance to slip. If you're using a timing belt, try to make the pulleys as large as you can. That way, the more teeth grip on the pulley, so there's less of a chance for it to slip. There are flat belts, which are like flat belts. They're like round belts, but they're like really stretched across. Those are typically used on transfers, where you want something wide that's moving to carry stuff throughout the robot. And I'm sure there are different types of belts, but those are the main ones that are used in FTC. There's also chain. I'm sure most people are familiar with the concept of a chain. Basically a metal or plastic chain that goes around two sprockets, so as it rotates, the other one does. These are typically good. They're also really good if you don't have a perfect center distance, which you need for belts. You also can use gears. So most people are also familiar with the concept of a gear. So these can be plastic too, along with metal. Like we use plastic gears on this robot here. Most of the time, I think those are actually fine, but metal ones are good most of the time too, especially for high load applications. There's also direct drive. So for some mechanisms, direct drive might be useful, like a wobble goal mechanism this year. A lot of people just use the direct drive off of the motor in order to raise an arm. And then another good idea when you're doing power transmissions is to have a good and swappable ratio. So the ratio basically is how far geared down your motor is, so how slow the output is compared to your input. So if you have a big gear to go to a small gear, the smaller gear will spin faster and will have less torque. So you want the ideal amount of torque per speed, and you want to swap that out because you don't know exactly how far you can quite go. You can do calculations to get really close, but like this started out as 1-to-1 this season, and we eventually went down because we couldn't really know the ideal amount there. So drivetrain. So there are typically two drivetrains that are used in FTC. So Mecanum and six-wheel drive. So Mecanum drives are drives, you can look them up. So they basically have 4 wheels and 4 motors, so you can move any direction on the field at any time. These are great, but they can be pushed around easily. So another drivetrain is six-wheel drive. So basically 6 wheels on the ground. These are great for good traction and difficult to push. And of course, the drivetrain shouldn't be complex at all. It should be the mechanism that works 100% of the time on your robot. And it should be able to withstand a beating because a while back we had some pretty weak drivetrains and those just broke. And it's a pain to see your robot stop moving on the field. So make sure they're pretty robust. So the next thing I want to go over is intakes. So intakes should be touch and own. So there are typically game elements, and you want to get these into your robot as fast as possible, and you want to keep them. So Robonauts, a great FRC team said, like, so you should be able to touch and own it. Like the moment you have your hands on it, it should be yours. And then spin to win, typically really good intakes are spinning. Most of the time, like 95% of the time, an intake's gonna spin. And then the fastest RPM on an intake doesn't really mean the best though. So in 2019, you had to have these for Skystone. You have to have we used wheels in order to take in blocks. So the wheel would go on a block and to go into your robot. But the problem is that we made them way too fast. And so as they try to put in, the motors would stop because they don't have enough torque to push it in. And so you have to find a good balance between the two. Then there's surgical tubing versus wheels. Surgical tubing is commonly used on intakes because they just really slap everything into the robot really quick. And then wheels are also used sometimes. Surgical tubing's typically good for like small balls or cubes, while wheels are better for, say, larger objects like the blocks in Skystone. You can see that in the bottom image there. That's where wheels might be useful. And then ideally, with an intake, you should be able to plow into the game elements and control them immediately. Like there should be no thought on the driver's spot. Maneuvering around, going into these little places. No, it should be bam. You should have it. And then another big part of the robot is your transfer and outtake. So slides are typically used in FTC. Like this was like the only year you could get away without using slides. Usually every year there's a very practical place to use slides. So that's an important thing to know how to use. There are a lot of guides on that, and you can contact us if you're interested. Arms can be pretty competitive too. On the bottom image and on the top right image there, those are 2 instances of arms on our robot, and both those robots did very well. So this is a virtual 4-bar. So there's a chain going to a sprocket, which can move, and then a fixed sprocket there. So as it rotates, the stone will stay parallel to the ground, which I guess is a lot of words, but there are a lot of guides on many different types of arms that you can see. So yeah, again, transfer and outtakes vary highly from year to year. So it's really good to look at past years and to see what teams have done, because in FTC, like even the blocks and white balls are being used again this year. So you can look into past years and see how other teams managed to take these into their robot and how they put them into scoring positions. And prototype these solutions yourself as well to get them ready for your robot. And so I'll just go over some design principles real quick. Hopefully I have time. So it's important to have a goal. So whether it's we're going to win the local league championship, or we're going to have a robot that scores this much every match. It's important to have and stick to those goals, or else you might be building something that you don't really. It's not really going to matter with what you're trying to do in FTC. Always build within your resources. It's important not to try to stretch yourself too thin. Like a lot of times, many teams will try to do everything at once, but they don't really have the resources to. They're stretched too thin. If you do one thing like super well, then that's amazing. Like even in Rover Ruckus, which is a game where you had a lot of things you can do, some very low resource teams just decided to hang and maybe get minerals if they could. But if you could hang every single match, you were looking really good for selection later on in local championships. So everything should ideally be prototyped. Like when you go into like designing things, you really want to make sure they work in the real life, or else they might not work when you build one just from your head. So try to design simple, design elegant, design reliable. That's just something I like to say. Just again, like a big thing that I feel most teams will hear is design simple, and that's really true, because especially with a simple robot, less things can break and there's less places to optimize, so you can put more of your time into different things. A big thing that really changed my outlook on a lot of things is to hold yourself to a high standard when building robots, especially in CAD or prototypes. Like it's okay if like prototypes are a little bit jank, but your real robot should feel locked in, and that's another bullet point at the bottom. Like you should be able to feel like, okay, this is going to work this match because nothing can really break. Like that's ideal at FTC. I feel like you want to have that feeling that it's going to work. Another thing is design for swappable components. So, and that also ties into your first iteration will probably not work. I mean, that just goes in the engineering process. If everything worked first time, it'd be a miracle, right? But they don't. And so it's important to be able to swap out components and optimize things during your season. Another thing, which I like to say, is build like you don't have enough time, because you really don't. It's a lot of work to build a robot. So if you can work fast and get a robot out quick, that's really useful, because it also gives time for software to program the robots to have a really good autonomous, and gives you more time to optimize it. So if you can build quickly. Another thing is 3D printed parts. So 3D printed parts are pretty great. They can take any shape. So it's very useful if you're thinking about designing a robot and you're running, well, how am I going to fit this here? Well, 3D printed parts can take any shape, so maybe we can use them. And every screw needs Loctite, and every nut needs nylon on a robot. So Loctite is a liquid where you put on screws. So, and they'll harden when you put in your robot, so vibrations won't make those screws back out. And then nuts with nylon is basically a lock nut, and those will also not loosen. So it's important your robot stays together instead of falls apart on the field, which some of our robots have. So it's really important that you do that. And then another huge thing in FTC is cycle times are important and milliseconds matter, especially for like top tier teams. Like cycle time. So how fast a robot can get the scoring element to the scoring position, and how quickly it can do that over and over and over again. Because eventually, like those seconds and milliseconds will matter over the course of many different cycles. And if Shane's here, he can talk about some of our robots.
Okay, so these are some of our robots from previous years. So there's kind of like three things that we try to like put in most of our robots: simplicity, reliability, and innovation. So a good example of simplicity was our 2017 robot, and it was pretty simple, and that got it very far. It only had 4 motors and simple 3D printed mechanisms. And then for reliability, our 2020 robot on the left was super reliable and almost never broke. We had about 2 of every custom part. And then for innovation, our 2015 robot used many 3D printed parts and custom wheels. And in 2015, that was pretty uncommon. I also had a rotating turret. But like overall, we usually just try to keep like robots like simple and reliable, because that's usually more important than having like a robot that can score really high but then can't do that every single time.
Exactly. One thing that it took me 4 years to learn this in FTC, but reliable robots will always win to a robot that's a high peak but can't do it often. It will always to go to the more reliable robot. So hopefully Sam should be here for software.
I'm here. This year we decided to use odometry as compared to PID that we've used in previous years. Odometry offered way more accuracy and reliability. It also had quite a lot of functionality for, I believe, adjusting headings and allowing us to kind of navigate freely on the field while allowing our drivers to focus on shooting all the rings into the goals. We used TensorFlow for vision tracking. It was really helpful, it was reliable. I think we had better luck with it than we did Vuforia. Our shooter also uses PID. It offers really good accuracy. It's why we had some pretty good shooter accuracy this year. On the bottom right, you can see one of our odometry pods that we used. And on the bottom left, we have our shooter PID. Brooks, could you move on to the next slide?
Yeah, sure. And just to reiterate what he said, odometry is used for knowing where the robot is on the field at all times. So that's pretty useful, but I'd suggest that most new teams start out with just time-based things.
Some of our software tools is Android Studio. We use that for programming all of our code. And we use ADB or Android Debug Bridge, which allows us to wirelessly push all our code to our Rev Control Hub. It's really useful and it's quite a big time saver. And then we use FTC Dashboard, which allows us to retrieve our Roadrunner data for odometry to kind of tune our PID values for Roadrunner and some of our navigation as well.
All right. So that was our presentation. Are there any questions?
Yeah, so looks like we have a bunch of questions. So I think first, there was a lot of debate going on in the chat. I just wanted to ask you guys, do you pronounce it McKinnon or McCannum?
McCannum.
There were some people in chat saying that it was pronounced McKinnon. I personally believe in McCannum.
I hear everybody say it differently.
Yeah.
I don't. We pronounce it McCannum.
Okay. Another question that you have is, what RPM motors do you use for your drivetrain?
Oh, okay. Yeah, so they're about 20 to 1 off of a 6,000 RPM motor, and I can't do the math in my head for some reason right now. But that's about what we use. So on GoBuild or AIMARC, you can find 20 to 1 or 19.2 to 1 motors, and that's an excellent ratio for most drivetrains.
All right. I think that should be around, like 400? If I did the math right in my head.
Yeah.
No, like 300. How about 300?
Okay.
Yeah. So we have that, and then someone said, "Is it feasible to use custom odometry instead of Roadrunner?" And
It is feasible to use custom odometry, but we didn't want to put in all the time to really make our own custom library, and we found that Roadrunner kind of had all the nice features that we wanted, and it allowed us to do it in about half the time.
yeah, another question that we have for the programming is, how do you tune your computer PID?
We have we had the code snippet in the previous slide, but I think without being in depth, we kind of just tune our like KP, KD, and difference in error values incrementally until we kind of get what we're looking for.
Yeah,
Alright.
like for tuning our PAD, one of our software members basically just went home and tuned it a lot just to get it good, like changing values and things.
Yeah. I don't think I see any questions in chat. One question I personally had for you guys is, a lot of teams that like us included use OpenTV for using the vision detection. Why did you guys decide to use TensorFlow? Because I know this is like a little more uncommon. So why did you decide to use that?
It was already available. There was a pre-trained model available by First, and we were able to implement it in like a few lines of code. So it just was good for getting a quick prototype out, and it was pretty reliable.
All right. Okay. I don't think there are any more questions I don't see anything in chat. So if there are no more questions, we're gonna move on to the next presentation.
Okay, sounds good. We can get
Alright.
started.
All right. So here. Oh, and before you guys start, someone's asking in chat, how is Abbas doing?
I'm doing well, thank you.
So you guys can go ahead.
All right. Welcome everybody to our presentation about the engineering design process. My name is Abbas.
My name is Ryan Stewart.
Okay, so I guess the first thing that's important is meeting the team. So we're Team 516 Gears of Fire. Us and our sister team 506 Pandara are the oldest teams in Florida. And we've been around since the first year of First. So I think 14 years now or so. And in the past 4 years, we've been pretty successful. In early recovery, we were a control finalist at the Houston World Championship. In Rover Ruckus, we won the Inspire Award at the Florida State Championship. In Skystone, we were a control finalist at Florida States. And this season in Ultimate Goal, we won the Think Award at the Florida State Championship and were second place in qualification matches at MTI, the Maryland Tech Invitational. So let's get into the engineering design process.
Yeah, so our engineering design process pretty much influences our whole design of the robot, including our subsystems. So like the subsystems, like the shooter, the intake, the drivetrain, everything is all kind of based around or like formulated around this whole 7-step process. So just getting started, our first step is strategizing and defining parameters, then drawing and prototyping, and then modeling, and then fabricating, and then testing and reflecting, and finally iterating.
Yeah, and so like as Ryan said, this is like what really drives us the entire season. Brooks and Shane were talking in the last presentation about how it's important to identify your goals, and that's definitely one of the big steps in the engineering design process. So before we go into that, I think it'd be good to show a little video of our robot, to understand like how the whole engineering design process turned out and what we ended up with at the beginning of the season or at the end of the season. So this is one of our matches from the Maryland Tech Invitational. I don't think there's audio, but that's all right. And so, you guys can see us, like this is the autonomous period. It's the same ultimate goal that everyone's played this entire season. But I think one of the things that's really important is the consistency we achieved in our robot throughout, like in MTI and throughout matches this season. And so, like after all of MTI was done, we had the highest tally-up OPR, which is something Ryan and I, as the drivers, are incredibly proud of. And I think most of it was because of how much driver practice we spent, because of how streamlined our engineering design process was, and like how much time we spent like planning everything out. And so if anybody has any questions about the robot in general, like while we're watching the match or while we watch a little bit of the match, go ahead and ask us those and we can answer them. So
Yeah, I think someone just asked, how was your experience at MTI meeting all the different teams?
Ryan, you want to go ahead?
Yeah, we had to scrimmage with some like the top teams like Brainstormers, Brainstem, Wolfpack, all like the top 10 teams in the world. So that was a really fun meeting everyone and seeing all the robots and even competing with some of the robots.
Yeah, I think also another thing I really enjoyed was like just seeing all of the teams there. I mean, every single team at MTI was like more than qualified enough to be there. You know, it was really impressive seeing all the time everybody had put into like the different designs. I know like I saw 14481 Don't Blink, and their robot was absolutely insane with like the double intake and turret. That was really cool. Another robot I really liked was probably Wolfpack. You know, they were a rookie team and they had like an in-house CNC and stuff, which I thought was insane. But yeah. So just to give a little overview of our robot and like how the engineering design process translated into that, we have four main subsystems: the drivetrain, intake, shooter, or the drivetrain, and then intake and transfer as one subsystem, the shooter, and the wobble goal mechanism. And so, you know, in our engineering portfolio, we go through the engineering design process for all four of the subsystems as like a separate page, and we'll show that later. But that's just an overview. So I think that's enough of the match. We can get into the different steps. Let's see. So the first step of the engineering design process is strategizing and defining parameters. And this is where you analyze the game, you know, read both of the game manuals, see where all the rules are, see where the penalties are, and you can find a lot of important things in there. For example, this year, I think it was GS8 that was particularly important in Game Manual 1, which said you can't launch horizontally more than 16 feet and vertically more than 6 feet. And so when we were testing shooters, we knew that one of the parameters of our shooter would be that it has to follow that rule. And so, you know, we would really make sure that any shooter we were testing couldn't shoot at anywhere more than like 14 to 15 feet. And it was like all of our shooters shot very low, pretty much like 4 feet like peak, because they would peak like right around where the high goal was. So really it was like 3 feet for the peak. And another thing that's really important here is outlining your goals for the season as a whole. You know, I think Pink Team talked about this a little bit, and they said like if you have to decide like what your team wants out of the season, right? Like, do you want to be the team that is your goal just to get first or second or whatever at the first league meet or all the league meets, or is your goal to just hit like 300 points every match or like 400 points, or, you know, anything like that? And I think another thing that's really important is outlining your goals for your specific subsystems. For example, with us, one thing we decided is we need a really quick drivetrain because we're going to be driving a ton this season. And this was geared more towards traditional matches. I know in remote matches, like with the vertical ring intakes and everything, there was like teams were driving a lot less. And, you know, it was more like the rings going in and the intake and transfer doing a lot of the work. But as a team, I think we focused our season around traditional matches because we hoped that we would be able to play those later. And so that's why a lot of our design decisions were focused towards that. And so like we decided we need a really quick drivetrain. And for our intake, we knew we wanted it to be as wide as possible and a touch it own it design, because in physical matches, there's a lot of situations where like two robots will go for the same ring. And I think that happened at MTI countless times. I think between us and Beachbots, it happened a couple times in practice. I remember us and Brainstormers were going for the same rings. And what was really important is because of our noodle intake and how fast our drivetrain was, we were able to touch it and own the rings all of the time. And I think some tips and tricks for the strategizing and defining parameter step is understanding the capabilities of your team, right? Like if you're a rookie team and you know that not many people on your team have the capabilities or the experience of operating like a CNC mill or a lathe or anything like that, then maybe don't try to make crazy parts that require things like that. But also, you know, if you know that you're a really experienced team who can build things very quickly and machine them very quickly, then maybe you should go for crazy designs like that. And I think the thing that's most important with this step is making a timeline. So when we decided to make, like after we qualified for MTI and we knew like we wanted to make some changes to the robot, we created a spreadsheet, or yeah, we created a table with like all the steps we were going to take for MTI and what like the timeline and plan was for all of them. And this included hardware and software and driver practice. And what's really important is just sticking to that, because it creates some sort of structure for the team, right? So it helps you like when the team knows when to meet. If you guys are a team that doesn't just meet like once a week, but much more often, I think we were probably meeting like 4 to 5 times a week when preparing for MTI. And so making a timeline is extremely important, but also you should understand it's very difficult to stick to a timeline. So like as a rule of thumb, I think I just like to add like a week's buffer in there, like just 1 week where anything will go wrong, or maybe software hits a bug or something like that, or you guys realize, oh, we just need more driver practice. And so giving yourself like an extra week in the timeline, while it might make everything else like crunch up a little bit, it does work out really well. It was just something I think we saw when we were building for MTI. Like we ended up doing 2.5 weeks of driver practice, where we would practice like Monday, Wednesday, Friday, 7 to 11 p.m. and then like 6-7 hours over the weekend. And that was like one of the biggest reasons we were so consistent there. So this is just an example of how we applied the strategizing and defining parameter step to our team this season. So this is something I learned from FRC Team 254, the Cheesy Poofs. And one thing they do in their documentation for the robot every year is they have like a table that has like the game aspect, possible points, priority, and criteria. And so I like modified it a little bit and made it so our team could easily read it and understand it and add to it. And as you can see here, like we have the different aspects of each period as a separate row, and then the possible points you can get from it and the different criteria, right? So like these are our parameters. And so for example, with the intake, you can see that we have touch it, own it as like the first must have. And then another thing that we had like early on in the season is that we knew we wanted to passively funnel rings. I think a big point of pride, or a big thing like Team 516 focuses on, is having a simple robot. Like as Team 6323 said, the simpler the robot is, like there's just less things to go wrong. And so like passively funneling rings would mean that we don't need like an active vector system that's just more servos that can break, or more gears that can that can like not mesh properly and things like that. And so you can see that we did this for every aspect of the game. And right now this isn't divided by subsystem, right? Like we're not having like the shooter, drivetrain, intake, and wobble wheel as having like must-haves, nice-to-haves, and exploring. This is just for different aspects of the game, and we haven't yet decided how we're going to fit those parameters, but we're just creating those parameters. And another thing you can see here is for scoring rings, we have to follow RGO8, and we want to shoot 3 really quickly, and things like that. And then like over here, you can see as a nice to have, one of them is just like we'd like to shoot from anywhere on the field, and we want to automatically turn to score. And these were things that like we did have, but we didn't use them all the time, right? Like we did have an auto aim system, but we just didn't end up using it at MTI because we thought it would be too inconsistent. Because we really hadn't tuned it to that field or anything like that. So yeah, if anybody has any questions about this table or like how we decided to do these things, definitely ask us about it. I'm sure our presentation will be made public because the Z.I.P Talks will like stay recorded and accessible on YouTube. So the next step is researching, and Ryan's going to talk about that.
Yeah, so I might have missed it on like the overview, but researching is definitely important. From researching FTC and FRC, I want to point that out. And it's important. I'm not saying just to kind of. I think it's important to gain inspiration from researching instead of and constantly upgrading another team's part. And it's important to look at previous years to understand the successfulness. And many teams throughout FRC and FTC have pretty much the same design. Like usually there's a meta in I can't remember what it was. It might have been let me try to think. No, not freight friendly. What's our one?
Oh, relic recovery.
Yeah, relic recovery, where it was like the kind of like the what was
The
that?
dump truck.
The dump truck. Yeah, exactly. So I mean, every year there's like a certain aspect of a design that just works very well. And then some tips and tricks. Yeah, I went over that to research both FRC because many teams do overlook that. Example. I mean, a boss can go over this. I think we pretty much touched on it already.
Yeah. And another thing is like, let's just say you're designing an odometry pod, or you're going through the engineering design process for an odometry pod. The researching step would probably be when you find out about open odometry or any of the other different solutions. And sometimes there's no point in always reinventing the wheel, right? Unless you're going for unless you're going for the Innovate Award or something like that. It's really about it's your goals, and most teams' goals are to do really well in the competition, right? And so we personally didn't go for open odometry. We really pride ourselves in the uniqueness and authenticity of our robot. But open odometry is a very successful, well-tested, well-tuned system. And so a lot of teams just decide to use the open odometry system in order to have a well-functioning odometry pod. And if you were research or if you were going through the engineering design process for an odometry pod, this is probably where you'd find out about open odometry. And so the way researching was applied in our robot this year is you can sort of see the inspiration we took from Team 254 Cheesy Poofs again. And so we saw Ultimate Ascent, the FRC game in 2013 had frisbees, which are sort of similarly shaped to the rings we had in Ultimate Goal. And so we looked at a lot of successful robots that year. And so you can see that the Cheesy Poofs design has this drop take, which flips out at the beginning of the match, and it can go up and down, and it has a top roller and a bottom roller. We have something similar in the sense that we have a drop take that flips out at the beginning of the match, and it has a top noodle intake, right? And so you can see certain similarities, but it's not like we completely copied the entire design or it's a one-to-one replica. Another thing you can see is that both of us have same side designs in that the frisbee enters from the front of 254's robot and exits from the front. And with us, the ring enters from the front and exits from the front as well. But here again, it's a completely different approach in how the ring gets to the shooter. And so for 254, it's similar to 6323's design from this year, where the ring or the frisbee would go in and around in sort of an arc all the way around the robot. And with us, it's different in the sense that the ring goes to the top and then just falls down in a straight line. And so while we did take inspiration, we didn't completely copy the design because we thought, oh, this idea would be better, or it'd be simpler to make, or it would fit more to our machining capabilities. And S Lord Voldemort in the chat looks like they have a question. Yeah, is having a high scoring robot more important than a unique robot?
Yeah, so I mean, I kind of think it depends on what you're going for. If you want to leave your, I guess, your fate up to the judges, a unique robot might be the way to go. And well, I think the most important thing for us that we found is having a consistent robot is really what's best. Because I mean, I don't want to downplay Brainstem, but Brainstem was a high scoring robot in all aspects of the game throughout the season. However, when they kind of entered that
MTI field.
Yeah, the MTI field with the traditional rules and everything, where robots were constantly moving around the field, they kind of didn't do as well because many of their aspects were very unique, and we're not as consistent as our robot, as we've had tons of practice throughout. We had spent, I think I've also already said this, but 4 to 5 days a week, 4 to 5 hours in the day.
Practicing. Yeah, and also another thing to answer your question is, yeah, I mean, Chase just said it. That's exactly what I was about to say, is it depends on what your priorities are, right? If your goal is to learn as much as you possibly can, then then it's more important to design a robot that challenges you to learn as much as you can, right? And if you're going to be challenged by having an extremely unique robot Necromancers who had it? It was Necromancer. Yeah, how Necromancers had in Rover Ruckus, where they had the trampoline bot, then that's what you should definitely go for. But if your goal is just, to win, to score as many points as you can, then you should go for that high scoring robot. So I think it's really at the end of the day, it's up to you and what your goals are. Yeah. Okay, so the next step in the engineering design process, our third step is drawing and prototyping. So this is where you draw out your basic ideas and then rapidly prototype them. And I think the key word here is rapidly, because you don't want to spend like too much time on this step, because the next ones after this are really where you finalize the design. And so the main objective here is just to separate like the feasible ideas from the unrealistic ones, right? Like, for example, would it be possible to lift the rings into the robot using like some sort of linear rails or linear slide system, or is it possible to create like a bottom roller intake that leads into a transfer? And this is where we would find out those types of things. One couple tips and tricks I have for you guys here is that commercial off the shelf parts are your friend here. Actobotics, GoBuilda, Rev, Tetrix, all of those, like you can create very simple designs using those that should prove the basic ideas. And another thing that I think Pink Team also touched on is 3D printing. 3D printing can be very, very useful in the prototyping stage, because you don't need something extremely robust, but you just need something that proves the idea, right? And so, for example, this season, when we were prototyping our shooter, we used 3D printed pieces to do it. And so you can see our shooter right here this was our prototyped shooter gearbox. And you can see that it's all just commercial off the shelf Actobotics parts, the Actobotics gears, then the motor mounts. And I guess there's a little bit of GoBuilda in there too. But Actobotics gears, and then just a wheel from Andy Mark. And then just for the base plate, like it's an Actobotics base plate where we countersunk the screws just so they wouldn't tear up the rings. And you can see that the way we did this to test it is we had 3 different setups. So we had one setup where we tested a straight shooter, meaning we just had a piece of channel that was mounted on top of on top of the flat plate, and we would just put the ring through and see how it would shoot. And then another design we had was where we had a 90-degree arc with a certain amount of compression, and we would just put the ring through and see how it would shoot. And then the final design we had was a 180-degree shooter, and where we would just put on another 90-degree arc and test it and see how it would go. And so with this, we could very easily, within like 4 or 5 screws or 4 or 5 bolts, just test how 3 vastly different shooter types would work. And it was just really effective in helping us decide like what type of shooter we wanted. Another thing that you could have done here, which is I know some teams did, is add like slots to your curves so you can adjust the compression. And that's not like we would have, or we knew we wanted to test different types of compression, and so like we probably should have done slots. But I think we just got a little lucky with the first compression we tested, and we were like really happy with the results, so we just stuck with that. So yeah. The next step of the engineering design process is CADing. So Ryan?
Yeah, some teams do use CAD to fully CAD out the robot before they even build it. We kind of use CAD to like assist us on like what the kind of like the idea that we were going for, and then we would like iterate our design from the CAD and then put it on our robot. And as the overview states, there are many different CAD softwares. We choose to use Fusion 360 because our school supports it. And tips and tricks, this is it does make sense to make sure all like the bolts and nuts are into the system, so everything is mounted properly.
Yeah, and like one thing that's important here, so like one example for like modeling all the bolts and nuts is when we were designing our intake this year, like we already had the drivetrain, or like the second version of our intake. We already had the drivetrain designed, right? And so there were a lot of bolts and nuts right around the area where the transfer would connect to the drivetrain. And so we had to make sure that like all of the belts and the pulleys and everything would miss all of those bolts and nuts. And it's like if we didn't have those modeled, we would have definitely hit some of them when we were going to assemble it, and then just would have had to make like a ton of changes to the system. So the fact that we had them beforehand helped us a lot. And to touch a little more on the CAD softwares available, all of those are solid options. We use Fusion 360 A because it's free, and B because the the cloud storage is really nice because you can share designs with your teammates really, really quickly. I know Onshape is just like that in the sense that it's like a cloud-based system and you can like edit. I don't know if you can edit designs at the same time, but it's really easy to like share designs with your teammates. And then SolidWorks is like the sort of industry standard CAD program, and it's really, really good. It's really powerful in what it can do. It's the only thing is it's difficult to share files between your teammates, right? Like unless you have some sort of file sharing system already set up and things like that, you have to like just constantly send the files to each other and then open them, make the changes, come back and things like that. And it's easy to like lose like, what's the most updated file or like who has the most updated file, and things like that. But I think really what's important is just use what's best for you. Try them out. Fusion's free. Inventor, I believe, is free. I know Onshape is free, and with an education account. And SolidWorks, I know Game Manual Zero has a link on how to get SolidWorks for free as well. So you really shouldn't have to pay for any CAD softwares. So give them all a try, see what you like best, and do that. I think someone in the chat had a question, Ankita. They said, "Is it hard to keep all your parts organized when building your robot?" Um, so I think I'm not sure if you mean like when physically building it or when designing it in CAD. So when designing it in CAD, what we've done is just sort of amass a parts library throughout this season that we share with all the other teams. And so we spent a lot of time in making sure it was really, really organized and like nobody would move the parts around so that you can always just find whatever part you need. I know some other teams have also made part libraries for like Onshape. I think Team 2901 Purple Gears has one that's pretty extensive, and I think some other teams have recently also put out some parts libraries. And then when we're building the robot, it definitely is. Yeah, it's pretty difficult to keep everything organized. But bins are helpful. Like when we were disassembling our Go Builder mechanisms to paint them and just make sure they were all good and everything, we just had like a storage case that had like a bunch of little compartments, and we just put the different pieces in each compartment, like the E-clips or the shafts or the rollers or the bearings, and things like that, which helped. Yeah, I don't know if I have like any really great solutions.
It's kind of like organized chaos.
Yeah.
There's kind of tiers to it. So like we have an organization system at our club, and then we have a personal organization system for our for just like our team, and then we have another one. Where we build and at a boss's house.
Yeah, and like definitely storage bins and things like that are really, really helpful. For screws, like one of our mentors, what he does is like he has a lot of old pill bottles, and so we put our bolts and nuts and things into those pill bottles and then label them on the top so you like know which size bolts you're grabbing. That's helpful. I mean, it does take a lot of work, but it is very, very nice to have like all of those things organized and easy to access. And so, as far as the CAD, like you can see, this is the CAD for our intake and our drivetrain. And so, this CAD has every single aspect of the intake. It has our servos to pull the drop take. It has the chain, the hood, everything. And so it's really important to get all of this done. So like, there's no surprises when you go to build. Like there always will be like one or two things that you don't expect, but it's important to mitigate as many things as you can. Yeah, and then with our drivetrain, you can see like this is the old drivetrain with the Nexus mechanisms, but the idea is still the same, right? Like everything is in there. We have our dead axle because what we did this year and last year actually is we dead axled our wheels off of quarter 20 pan heads and then just have a nut on the other side that constrains the pan head, and then the wheel just spins around that in a bearing. So it's really important to have all of this planned out. It'll save you a lot of frustrated nights in the future. Yeah. So the next couple steps of the engineering design process, I think we can just combine as they sort of like cycle through each other really quickly. And so this is fabricating, testing, and iterating. And so the fabricating step is, just where you machine your parts or order them if you're going through a company like Send Cut Send, or just get the commercial off the shelf parts, from your storage room or wherever, and you just assemble everything. So with regards to fabricating parts like from scratch, the best thing is to make templates, right? Like if you have like a bandsaw and a drill press, what we've always done is made a drawing and put center marks on all of the holes and then make sure the scale is 1:1. And we print that out and then double side tape it or single side tape it to the piece and just follow those lines on the drawing or the center marks or whatever and make all the pieces. This makes it really, really quickly. This makes it really easy and quick to make any parts. And also what's really nice is you don't have to measure anything, right? Like you don't have to say like, oh, this hole is 8 millimeters to the right and then 4 millimeters down, and the next hole is over just the same amount. All you have to do is just punch each one with a center punch and then just go up and down with the drill press on all of the holes, making it really quick. Another thing though, if you do have to measure things, make sure you measure twice and cut once. You can't undo a cut on the same piece, and it's really frustrating if you do mess up and you have to go back. And besides, things are expensive. Like polycarbonate can be very expensive for sheets. Aluminum can also be decently expensive, but it really just, it's frustrating and it sucks when you have to redo parts just because you didn't plan them right the first time. And I think another thing that's really big, and I'm sure Uplift can talk a lot about this because they've been very successful with it, is contacting companies for sponsorships. I think one company that's been pretty big this year and last year is Send Cut Send. They'll machine parts for you like aluminum, polycarbonate. I think they do a couple others, but they laser cut them, and so it's really popular for teams to like send them their files to laser cut like their drive plates, their intake plates, shooter plates, anything like that. And they'll send it, and there's probably like a 1 to 2 week turnaround, and then you get them and you have your parts already done. This is really helpful because you can focus on other things during that time. The only thing I don't like about it is that like you don't get to make the parts yourself. Like I enjoy fabricating the parts, like spending hours on the drill press, bandsaw, sander, making sure everything looks really good. But it's really up to each team and like what everybody wants to do. And then the next step is testing. And so what's really important here is recording your tests. Like just video, like take a video of every single test you do, whether it's do it in slow mode, normal mode, like anything. Having videos is really, really useful because you can look back at it like frame by frame and see what went right, what went wrong, and like at exactly what point in time. And then another thing is to take notes about it and then make changes in your CAD first if possible. And so like I know with recording tests this year, one part in which it was really helpful was when we were working on our passive funnel for the intake, and that went through what, like 3 or 4 iterations, right, Ryan? Yeah, and so that went through like 3 or 4 iterations. You want to talk about it a little?
I mean, I the one that I was like more pointed to was the flicking mechanism.
Mhm.
We had a lot of trouble with the flicking mechanism, and we were kind of caught whether it was like the friction or if the flicker wasn't long enough, and we ended up saying that, you know what, it is long enough. However, we just need to do a few computer changes, as it wasn't going far enough in and out, and also it was going too quickly in and out, so it didn't have enough time to like fully slam the ring into the shooting wheel.
Yeah. And so iterating is probably the biggest step for any subsystem. You're going to do it many times for all the different components of the subsystem, and it can be really small or really large changes, and it'll continue throughout the season. Like for example, with our intake this year, we originally just zip tied our noodles to our intake axles, and then as we got throughout the season, we were seeing that like sometimes the intake would be like really bad, and so we looked at it and we saw that our noodles were just spinning around the axle. And to solve this, what we did is we just printed these little hubs that would go on the drop take, and then we would put these hubs that would just go on the drop take and then zip tie the noodles to those, so they would never be able to just slip around the axle. But a really large change that we did is we just completely changed our transfer design at the top of our intake. And so we went from like an actively powered wheel, compliant wheel that spun to push the rings through, to just a hood that the rings hit and then fell down from in order to go into the intake, which was a lot simpler and more effective. So here are some examples of like fabricating, prototyping, or fabricating, testing, and iterating from the Skystone year. And so you can see like this is for an intake, right? And we tested many different versions. So like this is like one of the original versions we had all the way on the left. It has 2 small green wheels and 1 big green wheel, and they're all chained together. And then you can see over here we tested one that had a blue wheel at the front and then a green wheel. And this was so like the different frictions, the different durometers of the wheels would allow the stone to align itself if it ever got jammed. And then over here we tested a foam wheel to see if like the additional compliancy of it would make any difference. Over here we tested 2 small wheels. Over here we even tested a cut wheel because we saw some teams had success with them in seasons like Rover Ruckus and Relic Recovery. And then over here, so this is a page, these are 2 pages from our portfolio this season. And you can see how we work in the engineering design process, as well as our method of documenting each subsystem as a whole. And so you can see at the bottom of each page, we have like each step in the engineering design process and like some important note about it, right? And so like in the shooter engineering design process, you can see that the strategizing and defining parameter step was when we decided between a straight 90-degree, 180 and 180-degree shooter, whereas the prototyping step was when we tested various shooter designs and compressions. And this is where we realized that a 90-degree shooter would be best for our needs. Yeah, anything else, Ryan? Okay, so I think that's the end of our presentation. If anybody has any questions, then definitely let us know. Okay, I think Shane just asked me a question. He said, how did you make the graphics on slide 16? Okay, so our entire portfolio was done from scratch in Adobe InDesign. So the renders are just rendered in Fusion 360, and then everything else just started as a blank page, and then I just went from there. For these the flame and the gears, I guess we did 2 even pages, so you can't see it. But traditionally, we have an even and an odd page, and on the even pages, we had flames as their bullet marks, and on the odd pages, we had gears. And that's just to add a little personality, like Uplift was saying when they were talking about the judging presentation and the portfolio. And so to do that, what we did is we made our own custom font and then made the flame and the gear the only things in that font, and had the bullet that font. And so that's how that worked. But if you wanna ask about like how we did anything like specific in design, definitely ask us those questions. We should be able to answer them. And then I think Ankita asked, do you guys make templates in advance? So last year for the engineering notebook, we did that a lot more than we did this year. The way we make the engineering notebook and the engineering portfolio every year is the first thing we do is our entire documentation team sits down and independently reads game manual part 1 and 2, as well as the judges manual, and just makes a list of all of the requirements of each award and just any other important requirements, right? Like, there's a 15-page limit. Like that's not included in a description of the Think Award, but it's just a general portfolio rule. And so they write down like it's honestly just the engineering design process, but for the portfolio and the notebook. And so we sit down, we write down all of the rules and like parameters and stipulations for each award and the portfolio and notebook in general. And then after that, what we do is decide the general outline we want to make for the portfolio. I think I should be able to show you guys that. We show the general outline we make for we write down like the general outline we want for our portfolio. And so this is like the most detailed part, or like this is the most important part of our portfolio each year, or the notebook, because it's really what lays out, like it dictates how everything is going to be laid out that season. So you can see like here, this is our ultimate goal notebook outline format. And so you can see like if we were to make a notebook this year, like we didn't end up doing it. We had all the content and stuff. We had most of the content, but we didn't think it'd be needed, and none of the judges ever ended up asking for it. But so you can see like we start with our team information, then we go into a subsection and then another subsection, and here we also assign who's responsible for each section. and we put any important notes, right? Like for the mentor bios, first doesn't want any last names in them. And so we do this for every single part of the notebook and then follow this to a T when we're making the notebook and making the notebook and the portfolio. And then for the portfolio, we made a separate outline. I think that file's like not on the Google Drive though. And so that's how we did it for the portfolio. And you can see like that really helps. And then we make the templates based on this. So like in Skystone, when we had like a full notebook, we had a template for just like a general title page or a template for like the entire hardware section, like that had like the backgrounds and like the tabs and all of those things. And so, yes, we do make templates in advance. But sometimes it's a lot more formalized than others. Like in Skystone, we would use master pages where we'd just be able to like I just send that file, and whoever was responsible for that part of the engineering notebook would just use those master pages and go from there. But this year it was sort of just copying and pasting the previous page and then changing the actual content on it. Yeah. Are there any other questions? Zip Ties, do you guys have anything for us or?
Yeah, it doesn't look like there are any questions, so I think I just wanted to say some things to close off the presentation then. So I just wanted to say to all of you guys who came, all of the different teams who came here, I just want to thank all of you guys for coming here. I know that it's like a wonderful experience as like a new team as to like see all these veteran team members to share all our experiences. Like when we were a rookie team, presentations like these really helped us out a lot. So we just wanted to thank all of you guys for coming here to present. Like when as like a fairly new team, like all of your teams have been like such inspirations for us, and we've always like looked up to you guys. So you guys coming here and helping out with these presentations are really helpful for us, and they're a pretty good experience. So I just want to thank all of you guys for coming to present. So yeah. So if there's nothing else, I I just want to I'm gonna stop the stream then. If there are no other questions, for everyone watching live who got to miss some of the previous parts of the stream, the recording of the video is on our Z.I.P Ties YouTube channel, so you can always go back and watch the recording again. And at a later date, I'll probably put up the presentations for all the different teams online. So thank you all for coming and watching us, and yeah.